Hey chemistry family, we are going to learn about the formation of solutions. So looking on a microscopic level of how these homogeneous mixtures actually form. So let's go. Before we figure out exactly how everything is going to dissolve in that, we want to remind everybody about what's electronegativity. Remember, electronegativity is that unequal sharing of electrons. Sorry, that's cut off a little bit, but it's unequal sharing of electrons, which means that in a bond, there's a positive and a negative end. So for example, if you remember, fluorine pulls on electrons much harder than hydrogen does. So that means that electrons are found more often by fluorine, which is why fluorine would have more of the negative charge and the hydrogen side would have more of the positive charge. That idea of positive and negative sides because of electronegativity is called polarity. And that's going to mean something to us when we look into mixtures and solutions. Because of the polarity, things can start sticking together. Specifically, we want to look at a very big polar idea, which is the hydrogen bond. Because in water's oxygen holds onto electrons much better than hydrogen does. Hydrogens have these partial positive charges. And another water will line up next to it, and an oxygen and a hydrogen will be attracted to each other. This force is called a hydrogen bond. And it's a pretty decently strong force that wants to have things stick together. Besides the hydrogen bond, which is the strongest of the intermolecular forces, there's also something called the London dispersion forces. This is basically a weak attraction between atoms, and we've gone through this in previous presentations, but because the electrons move back and forth and around in that, occasionally there's a side of the atom that is more negative than the other side, which is more positive. Because of that, atoms will want to be attracted towards each other. And again, that's why we end up having solids or liquids. It's because of these London dispersion forces. Again, a quick review of something we've already learned. The nonpolar and polar molecules just means if there's an equal or unequal sharing of electrons. All right, so something like this. Hydrochloric acid, because hydrogen doesn't have as many electrons as chlorine, because chlorine pulls on the electrons more, chlorine becomes more negative and hydrogen becomes more positive. Because it has that positive and negative end, we consider that polar. Now if we looked at something like this molecule where the four chlorines pull equally, the same electronegativity on the carbon, they would all cancel out and there'd be no positive or negative end, so that would be considered nonpolar. Again, no unequal sharing of electrons, therefore there's no polarity associated with it. All right? So now, when something dissolves in water, we form a solution. Let's look at something like sodium chloride, which is table salt. Say you sprinkle that in the water and swirl it around. What's happening on a microscopic level? Well, the sodium and chlorine ions end up breaking apart, and the water molecules surround each one on a microscopic level. So the oxygens that tend to be more negatively charged because of polarity surround the positively charged sodium ion, and the hydrogens that tend to be more positively charged go ahead and surround the negatively charged chlorine. So it literally breaks them down and breaks them apart. And because they're so small, the individual ions and surrounded by water, you can't see the individual pieces. And that's what makes it a homogeneous mixture. The process of the solute dissolving in the solvent is what we call solvation. All right? And this can either be endothermic or exothermic, depending on what's being dissolved in the water. All right? Doing something like mixing together sulfuric acid with water ends up getting very, very warm. It's very exothermic. But some things like potassium nitrate, which is a white solid that it's used a lot in like those freeze packs where you break them open and they get cold, those cold packs, I know that's endothermic because it gets colder. It's pulling in the heat, making you feel cooler. So anyway, solvation is the process of actually having the solute and solvent work together and eventually dissolving. Now, when things dissolve, you can speed up that process. And to speed it up, there's three things you can do. The surface area, the stirring of the object, and the temperature all affect them. So what does that mean? Well, surface area means that if you crush something up, you grind it up so that the water can come in contact faster with the solid, you've increased its surface area because more of the solvent can touch the solute at one time. So by increasing the surface area, you increase the rate of dissolving. Think of it like this: if you had a sugar cube. If you put the sugar cube in water, just plunked it in there, right? Would it dissolve quickly? Nah, it'd take some time. But what if you took that sugar cube and you crushed it up into a powder, and then you put it into water? Would that dissolve quicker? Absolutely. So by crushing it, you've increased the surface area. Also, we know, say you're making hot chocolate, if you just put that powdered chocolate mix into the hot water, it's not going to mix up as well and dissolve as quickly. But if you stir that in, now you're going to mix up that solute into solution much quicker. So by stirring something, you're going to speed up the rate of dissolving. And then, of course, temperature too. If you try hot chocolate again, but you try to dissolve that powdered chocolate into cold water, it's going to take a lot longer than if that water's already hot. The reason? Whether it's more surface area, more stirring, or more temperature, you basically increase the interaction between the solute and solvent, meaning that the water, in this case, is going to touch the cocoa powder in that much more often, which means that it will dissolve at a much quicker rate. Now, we learned about the term solvation, which is when the solute and solvent are working together to create a solution. But there's another thing that's called solubility. And solubility just is the amount of solute that can dissolve in the solvent. If you remember, we talked about something, solution being saturated or supersaturated. That means eventually you can no longer add and dissolve solute to a certain amount of solvent. So solubility tells you, hey, at what temperature and what pressure, how much can you actually dissolve in a certain 100-gram sample of a solvent? So it literally tells you, hey, if you have 40 grams of water and it's 30 degrees Celsius, how many grams of sodium chloride could you dissolve in there? So someone figured that out and created what's called solubility. Now, solubility is affected, as we said, we mentioned the temperature and pressure were mentioned. So what actually allows things to dissolve in each other? Well, one thing is the nature of the solvent. We talked about earlier that objects can be polar or nonpolar, meaning having a partial charge or not. If they are both polar, polar objects like to dissolve other polar objects. So that's why, like sodium chloride, which split up into its sodium plus and chlorine minus charge, dissolves so well in water, because water has partial positive and negative charges too, right? The oxygen's negative and the hydrogens are positive. So polars like to dissolve polars, but also nonpolars like to dissolve nonpolars. So something like gasoline or oil, things that aren't usually good at dissolving in water, tend to dissolve each other quite well, believe it or not. That's like if you ever got super glued together, like you super glued your fingers together, if you took mineral oil and slowly worked the mineral oil on the super glue, it will slowly dissolve it. Water's not going to help because super glue is nonpolar. So you need another nonpolar substance to dissolve it. That's why you use mineral oil. So, like dissolves like is the term we use for that. Polar dissolves polar, nonpolar dissolves nonpolar. Now, how much that can be dissolved into a liquid is affected by a few things. If we look at pressure and we look at a solution between a gas and a liquid, like soda, all right, it makes sense that as you increase the pressure on the soda, you increase the solubility of the gas, meaning the more pressure that pushes down on that gas, the more that gas can dissolve in the liquid. That's why when you open up a soda bottle, it goes psst, and you release all that gas. you had a high pressure system above the liquid, right above here on top, to keep the gas in. Once that gas pressure decreases, so does the solubility of the gas, and the bubbles form and come out of solution. Temperature also can affect how much gas can dissolve in a liquid. And we know that. If you take a sip of soda, fizzy soda, and you swish it in your mouth is going to warm up the soda. By doing that, if you increase the temperature, you decrease the solubility of the gas, meaning that the bubbles come out of the liquid more so. Now, if you're going to look at temperature for a solid and a liquid, though, it's the opposite, just like we talked about with hot chocolate. As you increase the temperature, you increase the solubility of a solid. So that's why in hot cocoa, if you have very hot water, steaming hot, you can dissolve way more hot chocolate mix at a quicker rate in hot water than cold water. And that's because the solubility increases as temperature increases for a solid and a liquid. All right, so we had some key words today that we went through, right? The term solvation is basically the interaction between the solute and the solvent. That's what's happening when something's dissolving. We talked about above solubility. Solubility is how much of the solute can dissolve in the solvent depending on the temperature and pressure. We also went over how pressure and temperature affect solubility, and they affect gases and solids dissolved in liquids in different ways. So we want to make sure you did understand that part. All right? Also, in the very beginning, we did talk about some different intermolecular forces, things you've already learned about before, but just to recap, right? Polarity, the idea that if there's unequal sharing of electrons because of electronegativity, one side of the compound might have more positive charge and the other side might have more negative charge. We also talked about London dispersion forces, which just means that atoms occasionally have a more positive or negative side to them just for a split second because electrons move around, and because of that you get interactions between the two. Now those aren't chemical bonds, but they are just little forces of attraction between them. All right? Hopefully this gives you a good idea of solubility. We'll be working on more solubility soon and upcoming, but thanks for taking notes. Thanks for listening.